And I would say this is one of those cases where MATLAB is pretty handy if you want to avoid some hairy operations. So let's do the same thing that we did before with this in MATLAB. So let me go over to MATLAB. Let's clear this one, and let's give ourselves some space, some more space right there. And now what we'll do is we'll create a new section. So that's going to be, this is going to be exercise chapter 11.1 exercise 15. Okay, so the first thing I'm going to clear all old variables. You do that with the command clear all, just like before. I'm going to define new variables. You do that with the command sim, and we're going to define x and y. And then I'm going to solve for my critical points by replacing the derivatives, because we're talking about first order here. By replacing the first order derivative, which is the slope, with 0. So the first equation is going to be 0 is equal to x times 1, and I'm just copying it from the handout. 1 minus x squared minus 3 times y squared. And now we want to put a second one. I put a colon here, and you'll see in a second y. My y prime is also 0, and that's going to be equal to what? It's going to be equal to y times, open parenthesis, 3 minus x squared minus 3 times y squared. And then all of that is going to be in our solve function. And the commas separate the different equations. Then we want to specify what we want to solve for. That's the variable part here. And then it asks you to put real and true if you want real answers, which I do, so I'll put that in a second. So I want to solve for x and y. And now I want my real, true, because we're only looking for real solutions here. And I want this to be outputted in xsol and ysol. And these are going to give me all of my solutions. And then I want to check my solutions, and I'll give you another trick here. So if you think a command is too long, what you could do is put 3 dots and bring it down. And this is the same thing as having it long over here, but it's nicer to see. Checking my solutions. Now I want to check. Let's do it with the first one. Let's just say that I want to check that this and this is actually 0 in my first solution. So to do that, I'm going to have ssol1 and xsol1, ysol1, and ysol1, xsol1, and ysol1. And the reason why is because I'm assuming we're going to have more than one answer, but this will take the first answer appended on this vector, which is going to be a 1 times how many vectors there are going to be, and it's going to multiply it by these. And since we said that we want the solutions that make the system true, we want the x's and y's that make this 0. So let's see how we did. Press Control Enter. We let it run, and we got 5 solutions. So it would have taken a while to do it by hand, and we did indeed get 0, 0. So we feel pretty confident, and that's how you can solve or find critical points for a nonlinear system pretty fast, and assuming MATLAB can handle it. I hope this was useful, and I'll see you next time.